Hey everyone, in this lesson we are going to solve problem 4 on the collection of problems on lists in Haskell. So this problem 4 says, define and implement a function with the name of average that given a list of integer numbers, it returns a float number, which is basically the average of this list. Okay, so here we can see a pair of examples. It is very simple, okay, to understand. If we compute the average on the list that has the integers 1, 2, and 3, this is basically computing the average of these numbers. So the output is 2. Remember that the average of a series of numbers is the summatory of all the numbers divided by the number of numbers. So basically we have to sum 1 plus 2 plus 3, right? This gives us 6 divided by 3, which is the number of elements that we have 2. So again, if we compute the average, we apply the average function to this list that has the elements 8, 1, 3, and 9. We sum these elements first. So we have 9 plus 3 plus 9 is 21. So when we divide this 21 by 4, which is the number of elements, we have this result, 5.25. Keep in mind that the input is a list of integer numbers, but the output is a real value, is a float value, okay? So let's start the resolution of this problem. The first step is going to the terminal on our operating system. This is the same whether you are on Mac, Linux, or Windows. In this case, for this problem, we are working in Windows. So we just go to a directory that we have, the Haskell file, or where we will save the Haskell file, right? So we have created a folder with the name of Haskell, okay? And inside this path, this directory, we have a Haskell file with the name of average. In Windows, you can list the files within a directory with the dir command. So if we press enter, here we see that we have the file average that has 0 bytes because we have not written anything yet. So let's just start and open this file. So here we have the Haskell file, okay? The name of this file, we set it to be average because the name of our function is average. You can set here any name, for instance, problem 4. What's mandatory is that you use the extension HS, okay? So we indicate that this is indeed a Haskell programming language file. So with this said, let's start with the definition and implementation of this function. The first step on defining any function in Haskell is, if we do not want to use the automatic inference type system that Haskell provides, we need to give its type, okay, its type header. Keep in mind that this type header definition is already given in the problem statement, right? Average, as we see, is a function that given a list of integers, it returns a float number, which is basically the average of all the elements that belong to this list. So we can copy this type header. Average is the name of the function. The input is a list of integers. The output is a float number. Okay. So with this we have the type defined. So how can we define the average on this? Well, we will define the average with a local name definition, and we will just say that given a list, let's just say the input x, okay? Here we are now already implementing this function. So given a list x as an input, this is the list of integers that we have. Well, the average is basically the sum of the elements. Okay, let's just compute this with the name of sum_ln, okay, divided by the length of this list. So let's just call it len, okay? So Haskell does not know what this is, and also, okay, neither it did not knows what the length is. So since Haskell doesn't know what the sum of the elements is and also does not know what the length of the list is, we need to provide this information, okay? So how can we provide this? Well, we can use a where, okay? This is a local name definition. We can define now what is the sum of the elements and what is the length of this list, okay? Remember that this is named, this mechanism is the local name definition in Haskell. So how can we define the sum of the elements? Okay, well, the sum of the elements is basically the sum of this list. This sum we can access and apply this as the function sum. Okay, so we can just say that the sum of the elements is the sum of x, but here we have a problem. Which student can tell me what problem we have here? Well, the problem that we have is that we have a conflict of type. The conflict of type is basically that here is a integer, okay? If we sum integers, what do we have? We have integers, okay? If we have a sequence or a series of integer numbers and we keep summing them, at the end we will have an integer value. But why is this a problem? Well, because we need a float at the end. So we will convert this value to a float number and also the length into a float number, so we can basically apply the real division, which is this symbol. Keep in mind that in Haskell, when you write this symbol, this is a real division, and when you write the div method, this is an integer division. Okay, for this problem, we want the real division. So we need to convert this sum element from integer to float. So the result we need to be float. So we can just say this to be from integral, like that. So from a integer value that we have, we will return a float number. Okay, so in this way, what we're doing in essence is that we have that the sum of the elements when we do the sum is a integer number, but we need to convert this value, which is an integer, to a float, so we can just apply this. Okay, from integral with a value n, okay, imagine that we have a value n. Well, this function, what this function does is basically transforms this value on the input, which is an integer, to another value. And this another value is a numerical value, okay? It belongs to the class of the numerical number. So basically we can have double, we can have float, okay? We can have any type of numerical value in Haskell, okay? So here we are applying the float because here they specify that we need a float value. If they had specified with more precision, with the double, then we need, or we would have needed to change this to double, right? So with this, just remember that this function converts this integer value to a numerical value that we specify. And the one that we are specifying now is the float, okay? We are converting this to a float number. Now the length, well, the length is basically a very analogous mechanism, is a very simple one, okay? As we see, this problem is not a hard problem, okay? It is not a complex problem. Basically, the length is the length of this list x. So we apply the length function, length of x, and here we have to convert also the length to a real value. So from integral, this argument on the input is an integer value, and we transform this to float with a from integral function, right? And with this we have specified what is the sum of the elements and what is the length of this list. So what is the average? Well, the average is the sum of all the elements, okay, divided with real precision with the length. That's why you need here to have float numbers, because we are applying the real division, okay? That's the cause to convert this to float, right? All right, very well. So with this, we finish the solution of this problem 4. Let's check and verify that this is working right. To do this, let's open the terminal and let's load this file, okay? So to load this file, the first thing that we need to do is open the Haskell interpreter. We can do this with the GHCI, okay? We just press enter. So now the Haskell interpreter is going to open. Once we have the Haskell interpreter open, we can load the file that we have programmed and all the code. Keep in mind that Haskell does not have the information and all the code that we've written. We need to load this information so Haskell can recognize this function. So we have named this file to have the name average.hs. So in the command line in the interpreter, we just apply load, 2 points load, and here we write the name of our file. If you've chosen another name, any other name, then you just write your file name and then .hs. So when we apply the enter button in here, we see that the file has been compiled, the module has been loaded correctly, and no errors have been notified. If there were any errors in our code, then the Haskell interpreter would have notified us. Now, let's check if this function average is working, and we will do this with the series of examples that the statement gives us at first. For instance, if we apply the average on the numbers 1, 2, and 3, this shall return 2.0. Keep in mind that the return value is a float number. So as we've said, we apply average to 1, 2, and 3. So this shall return 2. If we apply and we press the enter button, we get the expected result 2. Now let's check this second example, okay, with the elements 8, 1, 3, and 9. So we apply the average function to the numbers 8, 1, 3, and 9. And this shall return, as we see, 5.25, right? So we press the enter button and we get exactly and precisely this value. So as we see, this function is working properly. You can try and test with your own examples, with your own input list. For instance, we can just apply the average function to the list of the elements 9, 3, 4, 2, 4, 5, 6, 1, 8. So if we sum all these elements and divide those by the number of elements that we have, then the average we see that is 4666 until periodic value. Now this is important in many areas. Basically, we can apply this function average to calculate the average marks of a given student, okay, and see if this student pass. We can establish the criteria that if this student has a average greater or equal than 5, for instance, then this student pass. Otherwise, the student does not pass. Okay, so let's just try and see if this student will pass. Okay, we have the average of these values on the scale from 0 to 10. These are the marks. So we see that this student passes the subject because it has a value greater than 5. Well, you have many applications on this. So with this, we see that this function average is working right. We remind the student that you can download the solution of this problem 4 on the downloadable documents of this lesson, right, as a HS file, as well as the problem statement and the slides used.